Hello, pre-calc class. We're going to continue with what we were talking about yesterday. So, yesterday we were talking about counting, and we talked about some simple counting methods, the multiplication rule, and such. So, today we are going to be talking about something a little bit more complicated. I will try to explain it as clearly as possible. I hope you will listen carefully because this can be a little bit confusing. But I believe if you pay attention, you should be able to understand it. Remember, if you have any questions, you can always send me a message. I will try to arrange a time to talk to you one-on-one to help you. Please do that if you don't know what you are doing. Okay? All right. So, today we're going to learn a new word first. It's called permutation. All right, Permutation. Permutation. A permutation is an ordered arrangement of objects. All right. So, for example, if I say we are going to have a president, a vice president, a secretary, and a treasurer, all right? Well, those are distinct things and they have to be in a certain order. If, for example, if I say our president, let's write president, vice president, secretary, and treasurer. Let's say our president is going to be Michael, all right? And our vice president is Jay. Our secretary is Emily, and our treasurer is Gina. All right. Let's say that that's one way that we could do this. Now, this is an order. All right. It is an order, even though there's not a first, second, third. But we can say president is first, vice president is second, secretary is third, treasurer is fourth. It's an order of objects. In this case, the objects are people. All right. Because each of them, Michael, Jay, Emily, Gina, is different than Gina, Jay, Michael, Emily. That's different. All right. Because one would be, that would make Gina the president, and then we would switch the roles around. All right. So that's what we mean when we say order, in order. All right. It doesn't necessarily mean that there's first, second, third, fourth. It just means that the order makes a difference. If I switch Gina and Jay here, well, that's different because Michael, Gina, Emily, Jay is different than Michael, Jay, Emily, Gina, because that would mean that Jay becomes treasurer and Gina is vice president. All right. It's different. All right. So when we talk about order, that's what we mean. We just mean that the arrangement, if it's in a different order, it means something different. All right. So let's look at this example. It says, how many different permutations of the letters A, B, and C are there? Okay, well, let's try it. Well, we could have A, B, C. That's one permutation. We could also do A, and we could switch B and C, and it becomes C, B. All right, obviously. All right, are there any others that we could start with A? No, because A, B, C, A, C, B, there are no more that we could do with A at the beginning. So let's switch to B at the beginning. So we could have B, and then we could have A, and then C. Or we could have B, and then C, and then A. And could I have another B? No, there's no more B beginnings because these are the only two that are possible. Last one, C. Well, I could have C, A, B, and I could have C, B, A. All right, and these are all of the permutations. All right, there are no other ways that I could arrange the three letters, right? This is everything. So how many are there? 1, 2, 3, 4, 5, 6. There are 6. So the answer to this problem is 6. Now, when we only have 3 letters to do, it's not that difficult. I can write them all out. But if you go to 4 letters, it becomes a lot more, and it's very hard to write them all out. And then, what if you have 5 letters? It gets even larger. All right? So we need a rule, a way of doing this that's easy for even big numbers. And that rule is this. All right? So you need to know this rule. This rule is very important. In general, the number of permutations of n objects, and it says distinct objects. Distinct just means that they are all different, all right? A, B, and C are different, all right? That's distinct, all right? If it was A, B, B, that would be a different story. Then we would have to use something else. We'll talk about that later, all right? But if all the objects are different, then the number of permutations is this, n exclamation mark, all right, exclamation point. And the way we read this is n factorial, all right? And you probably have learned about factorial before. What is a factorial? Well, factorial is just n times, and then we multiply it by n minus 1, then times n minus 2, times n minus 3, n minus 4, n minus 5, all the way down to where we get to times 2, and then times 1. And then that's it. So this is n factorial. So it just means, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. All right? Now, in this case, how many different objects did we have? We have A, B, and C. That's 3 different objects. So the answer to this one, we could have also found out by just doing, instead of writing everything out, we could just do 3 factorial, which equals 3 times 2 times 1. Now, 1 doesn't matter, so it's just 3 times 2, which is 6. It gives us the same answer, all right? So the way we do this is n factorial. And most calculators, for example, this one in Windows here, has a factorial button on it. So you can hit 3 and then press factorial, and it tells you the answer is 6, all right? Now, for small numbers, it's not that hard, but when we get to big numbers, if we do even something just like 9, it becomes pretty big, 362,000, all right? So we're going to do a couple of practice problems with this, all right? So let's look over here. It says 12 skiers are competing in the final round of the Olympic freestyle. How many ways can the skiers finish in the competition? All right, we want to know how many different orders there are, all right, of the 12 skiers. Like this skier gets number 1, this skier gets number 2. How many different ways can that happen? Well, it's the number of how many permutations of these 12 skiers there are. So we can find the answer just by doing 12 factorial. Now, 12 factorial is very difficult to calculate out if you are doing it by hand. That's why you're going to want to use a calculator here. 12 factorial is 479 million, all right? Oh, it went away. 479 million. I already wrote down the answer. It's 001,600. All right, so 479,001,600 is the answer, okay? Now, B then says, in how many different ways can three of the skiers finish first, second, and third? So we're not worried about 4th, 5th, 6th, 7th, 8th. We don't care about that. Well, we can do it this way. We can use the multiplication rule that we learned yesterday, and we can say, well, how many different people can get first? Well, there's 12 skiers, so 12 of them could get first. All right. Then, how many can get second? Well, after one has already finished first, so there are 11 more. So there are 11 different skiers that can get second. And then finally, how many ways can we get third? Well, we've already had 2 skiers finished, so there are 10 skiers left. So that means 10 different skiers could get third place. So how many different ways can 3 skiers finish first, second, and third when we have 12 in total? It's this, 12 times 11 times 10. And if you take out a calculator and calculate that out, you get 12 times 11 times 10, and you get 1,320. And that's the answer. Okay? All right. Next, again, here we have 8. Oh, actually, I'm going to keep this because I need to keep using the calculator. We have 8 movies that are showing in the theater. Okay? And we want to find out how many different ways can we see all 8 movies. Well, again, that's just 8. How many different permutations of 8 objects are there? 8 movies, all right? We could see if there's 8 movies, A, B, C, D, E, F, G, H. We could watch movie H first, and then movie G, and then movie B, and then movie A. How many different ways could we watch the order of them? Well, it's 8 factorial. All right, and if you use a calculator to calculate that out, it becomes 40,320. Okay. And then this one says, in how many ways can you choose to see one movie on Saturday and one movie on Sunday? Well, on Saturday, how many different movies can we watch? Well, there are 8, so we could watch 8. All right. Then I'm going to assume that we're not going to watch the same movie again, right? So how many different ways can we watch a movie on Saturday now? Well, we already watched one movie, so there are 7 movies left. So the answer is 7. So all in all, we can watch 8 movies on Saturday and then 7 movies. We can watch 8 different movies on Saturday, and then we have 7 different movies on Sunday. So 8 times 7 is 56. Okay. So now this comes to where we have our general formula for permutations. All right. Up here, it's total permutations of n objects. But you can see that sometimes maybe we want to take out 3 and put them in order, and using the 12 different ones. They had 12 total skiers, and we wanted to take 3 of them out and put them in order. How many different ways of doing that is this? Well, that's where we get this general formula. And the way we write it is like this. So n, little n, p, r. All right. That's one way to write it. In your book, it actually doesn't write it like this. In your book, it writes it like this. P, n, comma, r, in parentheses. All right. These mean the same thing. All right. Sometimes some mathematicians write it this way. Some mathematicians write it this way. Some books have it this way. Some have it this way. It means the same thing. But the important thing is that the number of permutations of R objects taken from n distinct objects is given by this formula. N factorial, and then we divide it by n minus r factorial. Okay, so for example, let's look at this one. What did we do here? Well, we did 12 times 11 times 10. Well, another way we could have done that is 12 factorial, because we have n different skiers. We have 12 different skiers, and we want to take 3 of them and find all the permutations of 3 of them. Well, then on the bottom here, we're going to have 12 minus 3 factorial. Well, that equals 12 factorial divided by 9 factorial. Okay? But remember, what is 12 factorial? 12 factorial is 12 times 11 times 10 times 9 times 8 times 7. This is going to take a little bit. 6, 5, 4, 3, times 2. All right, that's kind of ugly. All right, and then we're going to divide by 9 factorial. 9 times 8 times 7 times... I don't even want to finish writing this out. Blah, 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 blah. But you can see that this and this cancel out. This and this cancel out. This and this cancel out. And everything's going to cancel out all the way down on the bottom and the top. All right, and what are we going to be left over with? This. 12 times 11 times 10, which is what we did before. So this general formula helps us to do this quicker, all right? So these are just some examples of using our calculators to figure out permutations. So, and actually this one wants us to do it without a calculator. So how do we do this? Well, all right, this is PNR. So N is 7, R is 3. So on the top, we're going to have N factorial, which is 7 factorial. On the bottom, we're going to have 7 minus 3, because that's N minus R factorial. All right, so that's 7 factorial over 4 factorial, because 7 minus 3 is 4, right? Okay, well, that means 4 times 3 times 2 times 1 are going to cancel out on the top and the bottom. So we're just going to be left with 7 times 6 times 5, right? Because if 4, 3, 2, 1 are going to cancel out on the top and the bottom because of this bottom here. All right, so we got 42 times 5, which is 210. All right, so we did it without a calculator. All right, good. What about 6 permutation 1? All right. Or sometimes we write it, sometimes your book definitely will write it like this, P6 comma 1. All right, and what does that mean? It just means 6 factorial over 6 minus 1, which is 5 factorial. Well, you should be able to see that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So the 5 factorials are going to cancel out, and on the top, all we're going to have left over is 6. That's going to be the answer. All right, and then finally, 4 factorial, well, that's just 4 times 3 times 2 times 1, which is 24. Okay. All right. Got that so far? Next, number 12. We are going to consider 10 different colleges. All right. We're considering 10 different colleges, and we're going to go visit them. In how many different orders can we visit 6 of the colleges? Well, that's how many permutations of 6 of the 10 colleges. All right. So that is permutations 10, 6, or in the book notations, it's P 10, 6, which is going to be 10 factorial divided by 10 minus 6, 4. So 4 factorial. Now we could go ahead and write all of this out, but it's going to be faster if we just use our calculator now. So why don't we do that? So let's take out our calculator. On the top, we have 10 factorial, which is this, and we're going to divide it by 4 factorial and hit enter, and we get 151,000, 200. All right. Now, what if we wanted to visit all 10? So that's 10 of the 10 colleges, all right? Well, that means we're just going to do 10 factorial. All right, the first college we visit, there's 10 choices. The second college we visit, there's 9 choices. The third, there's 8, 7, 6, 5, 4, all the way down. So then the answer to this is just going to be 10 factorial, which we can calculate is 3,628,000. 3,628,000, and then 800. All right. And that's it. All right, next. This one asks us, how many distinguishable ways can you arrange the letters M-O-M? Now, in this case, we have repeating letters. Remember up here, this formula only works, and this formula only works if we have distinct objects. Everything is different. Every object is different. Well, in this one, we have objects that are the same. M, all right? So we can't use the rule that we learned before, the formula that we learned before. All right, why don't we do this one without a formula? Let's just try and do it. How many different ways can we arrange these letters? Well, we could have M, O, M. Okay, then let's start with M again. Well, we could switch these two. So we get M, M, O. Okay. Could I start with M again? No, these are the only 2 ways that we can start with M, right? M-O-M and M-M-O. That's it. All right, so now we need to start with O. Well, there's only one way to do it with O at the beginning. It's M-M, right? So that's it. These are all of the ways that we can arrange these letters that look different, right? There's no other ways to arrange M-O-M. So the answer is 3. Okay? Now, we're going to learn another formula here that can help us to do these kind of problems even when we have larger amounts of letters, all right? So, the number of distinguishable permutations of n objects where one is repeated Q1 times and another is, this is actually written wrong. The notebook has a mistake. This should be a Q2 times, and so on, is like this. All right. Now, what does this mean? N factorial divided by Q1 factorial times Q2 factorial. All right. Well, in this case, with MOM, what it means is that we have 3 things, right? So we're going to put 3 on top. But then on the bottom, we're going to write how many times each of them repeat. So the M, how many times does it repeat? 2. There are 2 M's. So it repeats twice. So we put a 2 factorial. And then the O repeats once. So we put a 1 factorial. Now, 1 factorial is 1. So it actually, we don't really need to worry about if there are any things that repeat only once, we can actually just ignore it. All right, we just need to write the ones that repeat more than 1 time. So what do we have here? We have 3 factorial divided by 2 factorial. Well, 3 factorial is 3 times 2 times 1, which is 6. 2 factorial is 2 times 1, which is 2. So 6 divided by 2 is 3, which gave us the same answer as we counted before. All right? So this is a fast way of counting, and we'll do a few examples with this now. All right, number 14. All right, we actually have a lot of examples over here on this page. I don't think I'm going to get through all of them today because I don't want to make this video 40 minutes long. But let's do a few more examples. So we want to find how many different ways can we make permutations of these letters, O, H, I, O. Well, first of all, we count how many are there in total. 1, 2, 3, 4. There are 4 letters, so we're going to put that on top. Now, then we count repeats. How many times does O repeat? 2. There's 2 O's. And then H is only once, and I is only once, so we can ignore them. All right, so we're going to have 4 factorial divided by 2 factorial. Well, 4 factorial divided by 2 factorial is 4 times 3 times 2, which is 24. 2 times 1 is 2. So 24 divided by 2 is 12. That's the number of ways we can mix these letters and make them look different. All right. What I mean is, if we switch these two letters, it does not change it. So we don't count it. We don't count that. All right. That's why the number is different. All right. Next, let's do Mississippi. All right. Mississippi. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters. So on the top, we're going to have 11 factorial. And then on the bottom, we need to count repeats. Now, M, how many are there? Just 1. So don't worry about it. I's. How many I's are there? Well, there's 1, 2, 3, 4 I's. So we're going to put 4 on the bottom. How many S's are there? 1, 2, 3, 4. There's 4 S's. And then how many P's are there? 2. 2. So that means this is going to be our answer. And we can use a calculator to figure this out. All right, so we're going to have 11 factorial on top. And then we're going to hit divided by. And then I'm going to put parentheses because I want all of these things on the bottom. Parentheses, and I'm going to put 4 factorial times 4 factorial times 2 factorial, and then close my parentheses and hit equals. And the answer is 34,650. Yep. Ba-dum. That's it. Okay. Let's do a few more examples. All right, how many different vertical arrangements are there of 8 flags? All right, so we have 8 flags, and we're going to put them in a vertical arrangement. So there's 4 white, there's white, blue, and red flags. So it could be like white, blue, red, white, blue, blue, white, white. That's one way of doing it. How many different ways can we do that? Well, again, we have repeats here. And the repeats don't make a difference, right? If I have white, white, it doesn't matter which, if I switch those 2 whites, it doesn't matter, right? So this is going to be another one of those repeating ones. So we're going to say there are 8 total flags. We can put them in order. But there are 4 that are white, so those repeat. So we can divide those out. And there are 3 that are blue. So we can divide those out. And then there's 1 red, but we don't care about 1. That's not going to change anything. So the answer is going to be 8 factorial divided by 4 factorial times 3 factorial. All right, so we can do that. 8 factorial divided by, and then I use parentheses, 4 factorial times 3 factorial. Close the parentheses and hit enter, and we get 280. Ooh, 280. It's kind of ugly. Sorry. All right. Again, it says, how many ways can 3 Chihuahuas, 5 Labradors, and 4 Poodles and 3 Beagles line up in front of the judges if the dogs of the same breed are considered identical? All right. So there are the 3 Beagles. The 3 Beagles, they are all identical. It doesn't matter which order they are. All right. So this again is, how many do we have in total? 3 plus 5 is 8, plus 4 is 12, plus 3 is 15. So we have 15 dogs, but we have repeats. We have 3 Chihuahuas. We have 5 Labradors. We have 4 Poodles. And we have 3 Beagles. All right. So let me get the calculator out again. All right. So how we do this, we're going to write 15 factorial, and then we're going to divide and use parentheses for the bottom. 3 factorial times 5 factorial times 4 factorial times 3 factorial. and then close the parentheses and hit equals. And I got 12,612,600. That's the number of ways that we can arrange those dogs. It's a big number. All right. All right. I'm going to skip these ones. These ones are exactly like what we just did up here with these letters. All right. So you just count how many letters there are in total and then divide by the repeats. So I'm going to skip those for now. All right. I'll give you the answers. 6, 5,040. And then this one's 210. All right. Okay. So you can do it and check to see if you get it right. Let's go to this number 18. Number 18, a classroom has 24 students and 24 seats. Assuming the seats are not moved, how many different seating arrangements are possible? All right, how many different ways can we put 24 students in 24 seats? Well, the first seat can have 24. The second seat can have 23. The third can have 22, and so on. So the answer to this is just going to be 24 factorial. Now, it asks us to put our answer in scientific notation. Why? Because this number is really, 24 factorial is very big. Watch. 24 factorial is this number. It's huge. All right. Factorials go up very fast. All right. So 24 factorial is so big, so we need to use scientific notation. Do you remember how to do that? We write 6.2. We're just going to use 6.2, and then we have to count how many digits there are to move the decimal point over. All right, so we have 3 per each comma, and there's 1, 2, 3, 4, 5, 6, 7. So that's 21, and then 22, 23. All right, so this is going to equal 6.2 times 10 to the 23rd. That's scientific notation. And actually, I should write that it's approximately, because there's a lot of numbers back here that I didn't write. But rounding it, all right, we get 6.2 times 10 to the 23rd. All right, so a very big number. All right, next. This is like what we were just talking about at the beginning, where we have a vice president and we have a president and a vice president, and we're going to choose from a group of 10 people a vice president and a president. How do we do that? How many different ways can we do that? Well, this is just going to be how many different permutations are there when we pick 2 from 10, all right? When we pick 2 from 10. So this is going to be 10 factorial divided by 10 minus 2, which is 8 factorial. And that is just going to be 10 times 9, which is 90, all right? So there are 90 ways of picking a vice president and a president from 10 people. All right. Now, these are very similar to what we did yesterday. I don't really want to go through them all, but I'll show you real quickly. So, for example, we have a password. It needs to have 4. And when it says characters here, it means letters. All right, letters from the alphabet. And 2 digits. How many are possible? Well, if they can be repeated, that means the first one could be there are 26 letters, and then 26 letters, and then 26 letters, and then 26 letters. And then now we need 2 digits. So how many digits are there? 10. All right, so times 10 times 10. So this is equal to 26 to the 4th times 10 squared. And you can put that into a calculator and find an answer. All of these are similar to that, all right? So I don't want to really spend any more time doing these. This video is already almost 35 minutes long. So I will give you guys a homework assignment. The most important thing that we learned today are these two formulas. All right. All right. This formula is important. Very, very important. When we take our objects from n and we arrange them in different orders, this is how we calculate how many different ways we can do that. And then this one is if we have different objects, but they might repeat, and we want to find out how many different ways we can put them in order. All right, we use this formula. Okay, those are the two important things to learn. Let me know if you have any questions. I'm always available, so please send me a message on Discord or in our Google Classroom, and I will be happy to talk to you. All right, bye-bye.